Hi everyone. Today in this class we will discuss about graphs. Okay. So these graphs are basically used to display informations in the form of charts or in the graphical representation, which is easier to understand and to interpret the data, which makes the reporting process much easier and meaningful by using these graphs or charts. Okay. So when coming to these graphs, these are of again two types. One is the charts and the another one is the plots. Okay. So for this charts, GCHART is the graphical presentation. Okay. When it comes to plots, GPLOT is the graphical presentation and SGPLOT is the more advanced version. And these charts are of again bar charts, vertical bar charts, horizontal bar charts, pie, block, donut, star charts. Okay, we will see one by one. Okay, first let's see about the charts. A chart is nothing but graphical representation of data in which the data is represented as symbols, such as when it comes to bar charts, the data is represented in the form of bars, lines in a lines chart, and slices in a pie chart. Okay, let's see about bar chart first. In that we will see about Vbar first. Vbar is nothing but the vertical bar chart. Okay, see for example, now I want to show the distribution of student ages in the form of Vbar chart. Okay, so for that let's take rock chart. Okay, data equal to SAS help dot class. Okay, so now take Vbar. So Vbar is nothing but produce as a vertical bar chart. Okay, so for which variable I want to show the Vbar chart, I want to show the distribution of student ages. Okay, so that I'm taking age as the variable name here and run. Okay, and also quit, because most of the charts end with quit statement. Okay, let's execute this. See, now it created a chart with the frequency and the age. If we didn't mention any statistics, by default it produces the frequency. Okay, that is the count of number of students belongs to this particular age. But if we see our SAS help.class, we don't see anyone whose age is 11.4 or 12.6 or 13.8. Okay, so this is nothing but SAS places the numeric values on x-axis. So this is called as the x-axis. This horizontal bar is called as the x-axis and this vertical bar is the y-axis. So SAS places the numeric values. So these are the numeric values, right? So age values are the numeric values. So SAS placed the numeric values on x-axis in evenly spaced classes like a histogram. Okay. So if we want to tell the SAS to treat values on x-axis as the with one bar for each value of the variable. See, let's create a data set for the SAS help.class. Data test SAS set SAS help.class. Okay, now execute it. Now we can see what are the actual age values in our SAS help. See what are the age values, 14, 13. Okay, so there is no decimal values here, but in my chart what it gave me, see, it just gave me like 11.4, 12.6, 13.8. Okay, which is nothing but the SAS places the numeric values on x-axis in evenly placed, evenly spaced classes like a histogram. If you want with one bar for each value of the variable, like 11, 12, 13, 14 for each age values. In that case, we will mention a option called discrete. Okay, so what this discrete will do, specifies that a numeric chart variable is discrete rather than continuous. Okay, see, if I give this option, now I will get the actual age values on the x-axis. See, I got now 11, 12, 13, 14, 15, 16. Okay, so how many people are belong to 11 age group? 2. So this frequency is nothing but the count of number of students in this particular age. How many students belongs to 12 age group? 5. Okay, so like this we can create graphs. So in the place of V bar, let's take H bar. H bar is nothing but the horizontal bar. So this is the vertical bar representation, right? Now let's see about horizontal bar. Let's take the same example. Okay, in the place of V bar, I'm just giving H bar. Let's execute it now. See how I got my graph now. It is in which format? In the horizontal format. Okay, as I didn't mention which statistics that I need, in the H bar what it mentioned, it also gave the frequency for the age group, frequency values. Okay, see, when I execute this, I will get the V bar. Okay, so the next one, see, now we have seen about bar charts, which is V bar and the H bar. Now let's take an example for prop G chart. Okay, so prop G chart is nothing but the graphical representation of these charts. Okay, now in the place of chart, I am taking here G chart, and here also G chart. Okay, nothing is changed other than that. See, now my graphs are looking much better when compared to the normal charts. So this is the graphical representation of my charts. Okay, with by using the G charts. So here also let's use this G chart for the horizontal bar. See, my bars are in the horizontal format. Okay, so let's take an example for, see, for example, if you don't need frequency, you just need percentage instead of frequency. See, here it is showing you how many, here it is showing you the count, right? How many students belongs to this age group, particular age group. Now if you want percentage, in that case we will use the option called type. Okay, so what this type will do, specifies chart statistics. Okay, let's use percent. Okay, now it will give you the percentages. See, instead of count, now I got how many percent. Okay, so like this we can specify our statistics. Okay, and also we can use somewhere option. Okay, which computes average height for each age value. Okay, here we call height as the response variable. To declare response variable, we use somewhere option. See, here now what I will do is I am using the somewhere option. So what this somewhere option will do, specifies a numeric variable for sum or mean calculations. Okay, somewhere equal to, I am giving here height. Okay, so what this somewhere statement will do, if I give height here, let's execute it and see. Okay, so now what I got, I got age values here, and here I got height sum values. That means how many students belongs to 11 age group and their sum of height. Okay, and this is age group 12 and their sum of height values. Okay, if you want to give mean, you can give mean here in the place of percent. You can give mean so that you will get the average. Let's execute this. See, now I got the mean values, like it computed the average height for each age value. Okay, here we call height as the response. See, here we call the height as the response variable. Okay, to declare response variable, we use the somewhere option here. Okay, so see if I want to display what is the exact mean value for each age group at the end of the bar, in that case we can use the mean option here, because here we have calculated the mean value, right? So let's give mean here. Okay, mean, let's execute it now. See, now it display mean values, so that it will be easier for me to understand what is the exact mean values for this 11 age group. Okay, or else we can use group option also. Okay, see, let's take a group option. So what this group option will do, organizes the data according to the value of the group variable. Okay, group variable can be either character or numeric and is always treated as the discrete variable. Okay, let's take the group equal to, now I want to group this data based on the sex values. So here I am giving sex. Okay, let's execute it. Now it will give me the data based on the sex values. See, now I got female values separately, female height, mean value separately, and male values separately. For example, instead of getting this female and male values separately, I want to get both of them on same chart, but I want them to be stacked one above the other. Okay, in that case, we can use the, see here I have used a subgroup, right? Instead of group, if I use subgroup, what it will do is it will divides the bars into segments, okay, according to the value of subgroup variables. And subgroup variables can either be character or numeric and is always treated as a discrete value. See, if I use subgroup, now it will stack both male and female values one after the other. Okay, but it varies in the color. So for female values it is showing until blue, and for male values it is showing in the red color, that means stacked one above the other. Okay, so by using the subgroup option we can stack the data. Okay, and we have another option. If you want, see for example, if you want to get this both male and female values on two different pages, in that case we will use the, like, two different separate graphs, not included on the same graph or stacked like this. I want both the graphs to be present in the two different separate graphs. For that we will use the by statement. Okay, so what this by statement will do is it separates graph for distinct values of the by variable. Okay, now here what I want to do is, I don't need to use this subgroup because I'm not anymore going to use it. Okay, now I want to separate the by sex. So what we have learned from the day 1? So whenever we use by statement, we have to sort the data. Proc sort data equal to SAS help dot class by which variable? Sex, right? And run. And I want this to be created into a new dataset called test1. As I am creating this dataset for class dataset, let's change the name here. So let's give the new dataset name, which is class. Let's execute it and see. Now it should create two graphs, one for the sex equal to female and the another graph for the male values. Okay, like this, by using by statement we can get both male and female values on separate graphs. Basically we are sorting the data, okay, by using this by statement, okay, and which also produces the separate graphs for each distinct values of by variable. Okay, see for example, here you got both male and female graphs, right? Now you want only female graphs. For that we can use the where statement. See, instead of by, here now I am using where option, where statement, where sex equal to, in the quotations give female. Now you should get only female values. Okay, so no need of using this proc sort option. Okay, let's execute this. See, now I got only female values graph. Okay, so if I want 3D graphs, okay, now I want to create the 3D graphs. First we have seen just charts and then we have seen graphical charts, and now let's see about the 3D graphs. Okay, so for 3D graphs, here instead of Vbar, just simply mention 3D. Okay, so what this 3D will give? It will produce us the 3D graphs. Execute it. See now how my graphs are looking like. It is looking like in the form of 3D. Okay, so it's same for the H bar also. H bar is nothing but the horizontal bar. 3D. Okay, let's execute this. See, I got bar in the form of 3D. Okay, see for example, now I want to create the graphs with different colors, and I also want to change the width and also the shape. So for that what we will do is, here we have taken Vbar 3D. Okay, I'm just going to leave everything like that, but I'm going to include a option called pattern ID. What this pattern ID will do? Specifies the way fill patterns are assigned. Okay, now for pattern ID, what I am going to use is midpoint. Okay, midpoint is nothing but changes pattern every time midpoint value changes. Okay, let's use midpoint and execute this program. See, for every age values, for different age values, I got different colors. Okay, now I want to change the width of these bars. Okay, and also I want to change the shape of these bars. Okay, for that now what I will do is, let's give width equal to, okay, I'm giving here 10 as the width, and I'm giving the shape. Okay, shape equal to I'm just giving cylinder. Okay, let's execute it. Now my bars should look like cylinder. See, and width also got increased. If you give 20 as the width, your cylinders width will increase more. See, if you use 30, okay, let's execute it. It increased more. So like this we can increase the bar width and we can change the colors, okay, by using pattern ID, and also we can change the shape by using shape option. Okay, so same thing applies to the Hbar 3D graphs also. See, I'm taking the same options and copying it at the Hbar. Okay, let's execute it. You will get the same. See, I got the horizontal bars also in colors and cylinder shape, and width got increased. Okay, this is about bar charts, Vbars and the Hbars, and some of the options that we use in the Vbar and the Hbar. Next, let's see about the pie chart. Okay, so for this pie chart, let's take the same example. Here, instead of Vbar 3D, I'm changing it to pie. Okay, what this pie will do, creates a pie chart in which the size of the pie slice represents the value of the chart statistic for the category of data in relation to the total chart statistics for all categories. Okay, see, let me take off all these options for now. Okay, so now I want to create a basic pie chart for six female variables. Okay, and it is going to calculate mean values. Let's execute it. See, now it created mean of height values by each age group. Okay, so for which values I got this pie chart? For the female values, right? Here I have mentioned the female. If you don't mention female, see, if I take this off, let's execute it. Now I got it for both male and female values. Okay, now if you want to mention this statistic value, that is the mean value inside the pie chart, for that we will use the option called value. What this value option will do is, it causes the statistic value calculator to be placed in the inside. Okay, let's use the value option. Value, okay, value equal to inside. Let's execute this. See, now I got all my values in the inside the pie chart. Okay, see, now this is the pie chart for both male and female values, right? Now if you want both and male and female values to be separated in the same pie chart, for that we will use the slice option. Okay, what this slice option will do is, outside causes the value of age to be placed outside. Okay, let's give the slice. What this slice will do, controls the position and style of the slice name. Okay, midpoint values for each slice. Slice outside. Okay, places the text outside of the slice. Let's execute this. See what this slice has been done. It gave me the mean values inside and age values outside. Earlier without slice I got everything inside, right? So now after using slice value, I got mean values, that is the statistic values inside, and measure values outside. Okay, so this is about pie chart. Okay, let's see about donut chart. Okay, for this donut chart also, instead of pie here, let's use donut. Okay, so let's keep age discrete, type equal to mean. I want to calculate the mean, and somewhere is height, and value inside and slice outside. Okay, let's do the same for donut chart. What I got here, exactly same as the pie chart, but only difference is in the center I got a space or a hole. Okay, this is called as the donut chart. If you want to group it like subgroup, for that mention subgroup equal to, I want subgroup that by based on the sex values. Let's execute it now. Now how I got it? Inside I got male values and outside I got female values. Okay, and these are my mean of height and my age group values. Okay, and here it is defining the color for each age group. Okay, so this is about donut chart. Donut chart is simply same as the pie chart, but the only difference is in the middle it is giving a space. Okay, the next one is the star chart. Okay, star chart is also same. Okay, exactly the same. So here what I will do is, instead of donut, let's take the star. Okay, in the star, let's take off all this. Okay, let's create a basic star. Let's execute this. See, it created the chart in the form of a star. Okay, and I have my mean of height values outside and age values also outside. Like this we can create the star chart. If I want to group it, we can group it. Group equal to sex. Okay, let's execute it now. See, now I got separate charts for each sex variables. Okay, this is the chart for star chart for female values, and this is for the male values. And if I want to get only the female values, then I have to use the where statement. Okay, where sex equal to m. Everything is same, the only difference is it's changing here, like Vbar, Hbar, Hbar 3D, Vbar 3D, donut, pie, star. Okay, everything is same. Let's execute it now. Now it will display the star chart only for the male values. Now I didn't get it for the female values. For that I have used the where statement. Okay, the next one is the block chart. Okay, so let's create a block. Instead of star here, let's give the block. Rest everything is same. Okay, let's execute it. Now it should give the block chart for only the female values. Sorry, male values. See how I got my values in the form of a blocks. Okay, for the sex female male values. Okay, instead of only for male, let's give it for both male and female, and I want that to be grouped by sex. Okay, let's execute it. Now how I got my values? I got block chart for both male and female values. Okay, so let's use subgroup here instead of group. Let's execute this. Now it's stacked both male and female values one after the other by using the subgroup option. Okay, so these are the sum of the charts. We have seen bar chart, pie chart, block chart, donut chart, star chart, everything almost in all the charts same except this statement over here. The only difference is we are using the value and the slice options in the pie chart, which we don't use those values, those options in the other charts. Okay, rest everything is same, options, everything. The only difference is here we are changing the name of the statement like bar chart, Vbar, Hbar, pie, block, donut, star. Okay, so this is about charts. The next one is plots. Okay, now let's see about the plots. So in this plots we have again GPLOTs and SGPLOTs. First let's take an example for this plots. So for this plots I am taking proc plot. Okay, data equal to SAS help dot class. Okay, and I want to plot for age and height variables. Okay, so let's create a basic plot for age and height variables. Let's execute it. See what it gave me. It just simply gave me the height and age variables and it marked as the A. If you want to change this A to any other symbol, you can change it. Okay, see, now I want to change this age to, sorry, this A symbols to star. Okay, star or any other symbol, whichever you want, you can mention that. Okay, for that what we will do is equal to, in the double quotations, mention star. Okay, let's execute it. See, now it gave me the stars. Okay, see, for example, the next one is GPLOTs. So GPLOTs is also the same. The only difference is instead of plot here, we will give GPLOT. GPLOT is nothing but graphical representation of this plot. Okay. So if I give GPLOT, let's execute it. This plot remains the same. Only here it will changes to the GPLOT. Okay. Let's execute it. Now it will give the graphical plot. Okay. Here this is my graphical plot. It is giving on the x-axis I have height variables, on the y-axis I have age variables, and it specified the values. Okay, so like this we can create the GPLOT, which is the graphical plot, and for GPLOT also we can specify the symbols. Okay, see, for example, now I want to give the specific color for, see, now it is really confusing, right? For height values and for age values it is representing in the same color. I really can't differentiate which symbol is for whether age or for the height. So for that reason what we can do is we can assign symbol statement. Okay, see, for example, now what I want to do is I want to define color, height and values for the subgroup variables. So let's subgroup them based on the sex variable. Okay, let's execute it first. See, now I got for female values I got it in the blue color, and for male values I got it in the red color, which is subgrouped basically. Okay, so by using the equal to 6, and now I want to customize my plot by giving the color and shape and height also. Okay, see now what I want to do is I want to use symbol statement. Okay, by using symbol statement we can define the characteristics of symbols that display the data plotted by a plot statement used by proc gbar line, proc g counter and proc gplot. So now I am using this symbol statement for the proc gplot. Okay, in the symbol 1 I am giving. Okay, you can give symbol 1, symbol 2, symbol 3 depending on your variables. In the symbol 1 I want to give color equal to, let's give green. Okay, I want to take this green. Okay, and value. Okay, in the value we can mention the shape of the values. Okay, in the value I want to mention the shape, like for example diamond. Okay, and I want to give height. Height is nothing but it specifies the height in number of units of plot symbols. Okay, so now I am giving height is 2. Okay, so let's copy the same here. Now for symbol 2 I want to give color I want to give color yo. Okay, and shape I want to give, instead of diamond let's give triangle, and height is 2 only. Okay, and here I have taken everything same. Okay, let's execute it. Let's see now for symbol 1, see for the sex female values I got diamond shape. Okay, and the green color, and for male values I got the triangle shape and the different color. Okay, so like this we can assign the shape and the color for our values. Okay, so this is about GPLOTs and some of the options that we use in the GPLOT. Next, let's see about the SGPLOT. These SGPLOTs are again of 4 types. Okay, SGPLOTs are again scatter plots. Okay, series plots, step plots and box plots. Okay, let's see one by one. Okay, so these SGPLOTs are more advanced version for the plots. Okay, so let's see in this SGPLOT, let's see about first scatter plots. Okay, see for example here now I am taking proc SGPLOT. Okay, data equal to SAS help dot class, and here which plot we are explaining about scatter plot, right? So let's take scatter. Okay, scatter, and here we can mention which variable to be represented in which axis. So now x-axis I want to give height variable values, and in the y-axis I want to give weight variable values. Okay, Let's run and quit and create a basic SGPLOT now. Let's execute it. See, now it mentioned height in the x-axis, weight in the y-axis, in the form of, it mentioned it is in the form of rounds. Okay, so if we want to change the shape of these symbols and also size, we can do that by using the option marker attributes. Okay, here with a slash mention marker attributes. Okay, so in this marker attributes we can assign symbol. Okay, symbol instead of rounds. I want to give some other symbol. Let's give it a star, and I want to give size. See here, my round size is something, right? But now I want to assign some size. So let's give 4. Okay, let's execute it now. See, now I got stars and the size of the markers is 4. Now if I give, instead of 4, if I give 10, let's execute it now. Now my star sizes are bigger. Okay, like this we can change the shape and the size. Okay, let's give triangle instead of star now. Okay, triangle. Okay, let's execute it now. See, now I got triangles. Like that you can mention any shape that you want to get it in your scatter plot. Okay, the next one is the series plot. Series plot is also the same. Okay, let me take off this. Okay, the program is same. The only difference is here, instead of scatter we are giving it as series. Okay, let's create a basic series plot for x and y variables. Sorry, x and y axis, height and weight variable. This is really hard to understand. Let's change the variable names. Instead of height, here let's take name. Okay, let's take age here. Simple. Let's execute it. See, now how I got my values in the series. Earlier also I got with the scatter plot, it just gave me the points, but now it attached those points with the series plot. Okay, see, if you want to cross check, you can cross check that. See, let's take the same program, copy. Earlier mine was scatter plot, right? Let's take scatter. Okay, so if I execute it, now you can see the difference. See, this is my, here it is starting and it is giving like this. So in the scatter plots it just gave me the points, but here in the series plot it is joining those points. Okay, so this is series plot. But in this series plot, if you want to change the color of these lines, you can do that. If you want to increase the width of these lines, you can do that by using line attributes. Okay, earlier we have used marker attributes, right, for the scatter plot. Here we are using line attributes. Line attributes. In the line attributes we will mention color and thickness. Okay, color equal to, I want to give so basically we are giving for both the variables, right? See here, let's give for red, and thickness equal to, I want to give 9. Okay, let's execute it now. See, now my line color changed to red and the thickness is changed to 10. Okay, like this. If I give, instead of 9, if I give 15, it will be more increased in the thickness. My line thickness is more increased. Okay, like this I can increase the thickness and the change the color of my series plot. Okay, so the next one is the step plot. Okay, step graph. In the step graph also it's the same. See, for example, let's take the same example for the step graph. The program is same, but the only change is, instead of this we will be changing it to step. Okay, so for step graph also I'm taking, let's take name and height. Okay, let's execute this now. See, if you observe closely how my graph is looking like a steps. Okay, so now if I want to change the color or if I want to increase the thickness, I can use the line attributes here like earlier in the series plot. Okay, let's use the line attributes. I'm taking the same, copy. Okay, instead of 15, let's give it 5. Okay, let's execute it. See, now it changed the color and the thickness of the step graph. See, for example, now you want to create another line for, instead of name and height, I want to also create another line in the same graph for name and weight values. Okay, so for that what I will do is, you can give another statement. So how many lines you want to create for different measurements, you can give that many steps. See here, now I want to create another line for name and height. Okay, here instead of red color I will give green color. Let's execute it. See, now it gave for height values and for weight values. Okay, like that if you want to give for 10 variables, you can write 10 steps. Okay, 10 statements basically. Okay, so the next one is the box plots. Okay, in the box plots again we have, see, we have seen scatter plots, series plots, step plots, step graphs, and now the last one is the box plots. In this box plots again we have VBox and the Hbox. Okay, let's see about the box plots. See, here let's take an example, proc SGPLOT. Okay, basically all of these are SGPLOTs, right? SGPLOT data equal to SAS help.class. Okay, instead of step, scatter and series, now here I am simply taking VBox. Okay, VBox. Now this is for VBox is for age, and here what I will mention is category. Category, what it specifies the category variables for the plot. A box plot is created for each distinct values of the category variable. Okay, let's give some category variable here. I want to give for sex. Okay, let's run and quit. Okay, let's execute it and see. Now it will create a box plot. So understanding this box plot is very important. This center line is nothing but the median value, and this diamond or the dot is nothing but the mean value. Okay, So this is for the female and this is for the male values, and this center line is nothing but the median, and this diamond is the mean value, and this lower line is the minimum value. Okay, this lower value is nothing but the minimum value, and this upper value is the maximum value, and here this is nothing but the 20 75 percentage, and this is the 25 percentage. And when it comes to male, see, now you can understand this diamond is nothing but mean value, and this center line is the median value, and this is the 75 percentage, and this is the max value, this is the minimum value, and this is 25 percentage. Okay, so this is for the vertical box graph. Okay, box plot. For example, if it is for Hbox, Hbox is nothing but the horizontal box. Okay, the only change is instead of V here we have kept Hbox. Let's execute it. Now your box will be represented in the horizontal format. Okay, rest everything is same. Center line is nothing but median, mean, 25th percentile, minimum value, maximum value, 75th percentile. Okay, like this we can create box plots. Okay, so this is about some of the graphs like charts and plots that we have seen in this class. Thank you all.